continuation of the lecture about problem solving. We want to talk about optimization. So what does optimization mean? It means that how can you make the most out of something which is available? So let's look at this example. In this example, it says that we have 18 meters of framing. Find the R and H for the maximum area. So this is going to be a window, and then in this window we want to get the maximum area for light. But we have limited framing. We have only 18 meters of framing. So 18 meters of framing, meaning that your total frame will be 2R here, right? Plus 2H here, 1H here, 1H here, plus perimeter of a semicircle. So perimeter of semicircle is perimeter of circle divided by 2. Perimeter of circle is 2 pi r. So if you divide that by 2, so you're going to get pi r. So we have a pi r, we have 2h plus 2r. That's the first one, total frame that we have. In calculation of total area would be the 2r here times h, which would be the area here, 2RH, plus the area up there. The area up there is pi r square. So pi r square divided by 2, this will be the area of the semicircle. Now what we could do, how we go about this problem, we actually create spreadsheets. In reality, you have to use calculus to do this, but we want to just use with the spreadsheet with some numbers to calculate it. So what I could say, I could do from here, I can get the value of h in terms of r. I know the total framing is 18 meters. Then from here I'm going to get, just keep the 2h here, bring the other one to the other side. You're going to get 2r is equal to 18 minus 2h minus pi r. Sorry, I bring the 2h, I keep the 2h in this side. And then I bring the rest of them to the other side. So we're going to h 18 minus pi r minus 2r. From here, h would be equal to 18 minus pi r minus 2r divided by 2. So I found the h in terms of r. The next thing that I'm going to do, I'm going to actually come here. So in this case, I'm going to use, I'm going to put the value of h from here into this equation, and then I can calculate the total area. Now what we do, we set up a spreadsheet like this. In this spreadsheet, I'm going to guess the r as different values. I'm going to get r as like 1, 1.5, 2, 2.5. Again, this will be like an R to know what values you need to take for that. So if I know the R, I'm going to calculate the H, and I can calculate the area. So if you plug in 1 into this equation, you're going to get 18 minus pi minus 2 divided by 2. And then if I do this calculation, I'm going to get 6.43. Now I want to find the total area for this. I'm going to say 2 times 1 times 6.43. That's your h, plus pi, the value for r is 1, divided by 2. And then if you do the calculation for this, you're going to get 14.4. You can continue the calculation for the rest of them. Then you would be able to see where's the maximum area is happening. So in order to finish the calculation, actually I use Excel to do that. So what I did in the Excel is, in the Excel, I put values, different values for R. I put different values for R, assuming that R is going to be 1, 1.5, 2, 2.5, 3, 3.5. And then we calculate the value for H. Again, if you follow the tutorial for Excel, you would know how I do that. I just put the equation in there. Instead of pi, I put pi. So you see the equation is that 18 minus a times pi, which is a2 times pi, which will be like pi r, minus 2r divided by 2. That's equation for h. Once you have that, you can actually drag that one down there. Now the other equation I have the equation for, I have the equation for the area. So in the equation for the area, I put the same thing. So in the equation of area, I just use the equation for the area. Now I plug in the number there, then I create a plot. Now if you look into the value, you can see at 2.5, that's the place where we have the maximum area, which is 22.68. Now in the graph, you can see that it got to a maximum here, and that max happening at 2.5. This is how we solve problem in optimization. We create a spreadsheet, we look at the values, and then we plug them in there. Thank you.